My name is Barry. I'm a sound engineer in the Minneapolis-St. Paul, Twin Cities area. In this episode, we're going to talk about equalization, which is one of the greatest tools in pro audio. It's also one of the most misunderstood. So we're going to go over the uses of equalization and some of the limitations. Now, what we have right here is a pretty typical example of a nice graphic equalizer, and it's really just a tone control, except instead of just bass and treble, we have filters that cover the entire audio band, so you can make adjustments at any frequency that you like. And if there's too much energy at a particular frequency, you can just grab that fader and shove it down and reduce the gain. Or likewise, if you would like more output at that point, you just lift the fader up, bring it up. And in a 31 band graphic EQ like this, each of these filters are pretty narrow in bandwidth, and so you can grab a group of faders and make your adjustment accordingly to shape the band as you desire it to be. This particular equalizer, you'll see, also has a set of filters over here which are very narrow bandwidth filters that are cuts, and alongside each of those filters is a frequency adjustment range which is completely variable. So each of these filters have specific frequencies that they target, whereas the ones over here you can slide around in the band to get to an exact frequency you want to adjust. And the purpose of those controls is typically for feedback control. If your system wants to squeal at a particular tone, you can slide this filter in right at that spot, reduce the gain, and reduce the propensity of the system to feed back at those frequencies where it seems most unstable. So we can use equalizers as a tone control to adjust for feedback conditions where we can reduce the gain of the system at those particular frequencies where the system is unstable, therefore improving the gain before feedback within the system. We can use this for general tone shaping, so if an instrument has a little too much low end or high end or mid range, we can knock down or boost those frequencies to make it more acoustically pleasing to us. We can also use equalizers to try to correct some of the deficiencies in our loudspeaker system where the speaker output is weak or overly aggressive. And we can use equalizers to target deficiencies in our acoustical environment in our rooms. This is a pretty typical equalizer. It's a 31 band graphic EQ. It's a nice example of one. Also common today, you'll find parametric EQs, especially on a lot of digital equipment like this. And a parametric EQ usually only has a limited number of bands, like 4 or 5 or 6 bands, but that's usually enough because within each of those bands, like the bands on this EQ, but in a parametric EQ you can adjust the exact frequency that they are targeting, as opposed to graphic EQ where those bands are fixed in frequency and you can't adjust them around. But in parametric you can have a band and you can slide it up and down the scale here to any exact frequency you want, so it's a little more targeted. In addition, you can adjust the Q, or the bandwidth, so it can either be a really narrow filter or it can be a wide filter. And of course you can adjust the gain, whether or not it's boosting or cutting in that range. And I really like using the parametric EQ. And parametric EQs are, like I mentioned, getting pretty popular on a lot of digital equipment like digital mixing boards. And with the parametric EQ you can really dial in and target those frequencies that you need to adjust. Whereas with the graphic EQ you're somewhat limited by the bands that are available to you. Also with the graphic EQ, oftentimes you need to use several filters to target a wider bandwidth range. And all of this stuff does come at a cost. When you dial up EQ, it's not entirely 100% transparent. More often than not, you're introducing small amounts of phase shift, signal time delays, and it does distort the purity of your audio signal. particularly as you crank in a lot of filter. So this is one of those cases where I would suggest that less is more. You know, if you find yourself cranking in a whole lot of equalization correction, maybe you're not approaching the problem right. I mean, maybe you should be thinking about using a different microphone or different mic position, or, you know, changing other variables in the equation before just trying to gloss it over and fix it with equalization. But having said that, this can be a great tool, especially for shaping the tones of instruments, and for helping the system become more feedback resistant. Your loudspeaker system, your PA system, will tend to have feedback in those parts of the spectrum where the system is nonlinear. And so if you have an excessive amount of output at some particular frequency in your system, well, most likely that is probably the area where the system is going to feed back. And you can try to address those issues by reducing the amount of output coming through with your equalizer. Of course, having said that, the better your PA system is, generally speaking, the less propensity it will have to feed back. So if you have really good speakers and really good microphones and a controlled room, chances are things will be more or less pretty stable. On the other hand, if you're using inexpensive loudspeakers that have a lot of irregularities in their response, same thing with microphones, or if you're in an uncontrolled room which has a lot of reverberation, reflective sound, and has nonlinearity, so certain ranges are much less controlled than others. And also if your system is made up with kind of a mix match of equipment, so your stage monitors are like different models or different brands, and you're using different microphones from one performer to the next, all of those devices will have different response curves, and the system will tend to be less stable than a nicely set up high quality system. So the first thing to do is try to use good equipment, and then use the equalizer. The equalizer will not fix bad equipment. Same thing with loudspeakers. If you look at the specifications for a loudspeaker, you're going to find perhaps distortion, probably the amount of efficiency, which is how many dB of output in a meter that you'll receive with 1 watt of input signal, and a frequency response curve. And one could naively think that you could look at the frequency response curve of a loudspeaker, and those areas where it's deficient you could just boost up a little bit in the EQ, and those areas where it's excessive you could just knock down, and voila, you have flat frequency response out of the speaker, and you've converted a cheap loudspeaker into something great. But that's not really the case, because those things don't really show you the entire picture. For example, that frequency response curve may be true, but it's probably being measured directly in front of the loudspeaker. As soon as you get off axis a little bit, well, the whole game changes, and the response is probably going to be a little bit different, 45 degrees off of axis, and the corrections that you make on the equalizer will not be the correct corrections for that location off of the speaker. Whereas a really high quality loudspeaker system would probably have a much more consistent response from the audience sitting straight off of it versus the audience off to the side a little bit. So the polar response can have some impact, for example. And there's a whole host of factors in there that lets you not fix the problems with the equalizer. Some of those response peaks are actually resonance in the system, and you can't get rid of resonance with an equalizer. And that's a big point that I would like to get to. Everything in the world practically has some resonance, which is the frequency at which that device, that object, likes to naturally ring at. If you hit a large drum, you know that the drum is going to thump. If you hit a smaller drum, that will ring as well at a little higher tone. And the reason the big one thumps and the small one has a higher tone is because of their physical geometry, which causes a difference in their resonance. And it doesn't really matter if you hit the drum with brushes or a drumstick, that drum will have more or less the same tone. And I can illustrate that with this. So here's to you, my friends. It's a wine glass. And as you know, if you plunk a wine glass, it will ring. Now let's imagine that this wine glass represents your room. And so there's going to be some particular frequencies based upon the size of your room, how far apart your walls are and their materials and so forth. It's going to be certain frequencies that your room will want to naturally ring at. And let's say that the object that I'm hitting this glass with is putting energy into the glass as your sound system is putting energy into the room. So this would represent your sound system. And no matter how I hit this, the glass has that particular ring. Now, I can change the character of the sound system with an equalizer by boosting highs, or cutting lows, boosting lows, cutting highs, whatever. And that will apply a little different energy spectrum into the room. So instead of hitting it with my finger, let's hit it with this plastic pen, which would represent a little harder object, therefore a little more, let's say, mid-range frequency. Well, the initial impact does sound different, doesn't it? Because we're hitting it with a different kind of energy. But you'll notice the glass still has the same characteristic ring, that same tone, right? Doesn't matter what I hit the glass with. Let's say I boost the high frequencies up really majorly in the PA system, which would be represented by hitting the glass with this piece of metal. Much more sharp, isn't it? You hear a lot more highs. But you know what? The glass still has the same tone, doesn't it? Doesn't matter what I hit that glass with. The initial sound is different between my finger, which is soft, the plastic, which is a little harder, or this metal piece, which is hardest yet. Notice the initial sound is different, but the ring of that glass remains the same. And so it is with your room. You can equalize your band, and that'll make the initial impact sound of your band different. But the room is still going to resonate at the frequencies that it does. So if your room is going to yowl in the mid-range, the room is going to yowl in the mid-range no matter what you do with your equalizer. You cannot fix a bad room with an equalizer. You cannot fix a bad loudspeaker that has resonances in certain ranges with your equalizer. Okay? Does that mean that the equalizer is worthless? No. Because if you know that the room is going to have a lot of mid-range yowling with it, well, there's nothing you can do about that. You know, aside from fixing the room by either changing the dimensions of the room or at least putting in some sound-absorbing material to try to control those resonances. But you know that there's going to be excessive amounts of energy at those frequencies. And so the last thing you want to do is pump even more energy into those frequencies. So if I cut down those ranges on the equalizer, well, it doesn't fix the room, but it doesn't exacerbate the situation either. And so I know that there's going to be excessive energy there. I don't want to pour any more in than necessary. And you'll notice that the room will ring at that tone almost no matter what energy I hit it with. So you're going to get that. So that's one of my big lessons today is don't be naive and think that you can take a cheap loudspeaker system or a loudspeaker system with deficiencies and just slap an EQ into the equation and suddenly you have great loudspeakers. Now, I know that that's a strategy that Bose has gone after with some success, but it really does not produce high quality sound. And likewise, you can't just fix a bad room with an equalizer. You have to fix problems at their source if you want the best results. Another quick tip about fixing rooms is be aware of the difference between soundproofing and sound control. Soundproofing a room is the art of trying to seal up any of the little holes between that room and the adjacent room and putting in enough of a barrier between that room and adjacent rooms to try to contain the sound within a room and keep it from escaping into other parts of the building. Whereas sound control in the room is the art of putting in baffles and acoustic absorption at strategic locations to try to break up the echoes and reverberation in the room to give the room a more even response across the frequency range and provide a more comfortable and pleasant listening environment. But those sorts of adjustments and fixes will not necessarily have a lot of impact on the sound escaping outside of that room into other parts of the venue. Well, friends, I hope that these tips were useful to you, and I hope that you make good use of your equalizer. Try to consider that the less is more rule. So use the equalizer to great effect, but if you need to put in a lot of adjustment, keep in mind that maybe it would be best to solve that problem closer to the source than trying to fix it afterwards. It's kind of like making compromises in your band recording process and brushing it off by saying, we'll fix it in the mix. It's always a lot harder to do than fixing it at the source. So use the best equipment you can. Pay attention to the quality of microphones and loudspeakers you use, the placement of both the speakers and the microphones. Try to get the best results possible. And then from that point forward, use a little equalization to get it dialed in to the best of your ability. And understand that it's a great tool, but it's not a magic bullet either, and it has its limitations, and you can't fix bad stuff with just a little bit of electronic correction. Anyhow, I wish you well. I wish you many great band mixes. If you have comments, I'd be welcome to hear them. I'll certainly respond to any of your comments or questions that you'd like to put forward. If you enjoy the content, I would appreciate if you would subscribe, and we'll end that there. Hopefully I'll see you again soon with the next episode of Sound Advice. Thanks for watching.